Hello everyone, welcome to this webinar on Introduction to R Programming Part 2. Myself Gaurav Kumar, and I am currently an alumnus of IIT Bombay and working at Amity University as a program manager for the PG Diploma course in Data Science. And this webinar is brought to you by Careers of Tomorrow initiative under Amity University, where the initiative is to basically prepare our students for the new upcoming careers which are associated with the new technologies coming up, such as data science, machine learning and AI, digital marketing, blockchain technologies, and also business analytics. So today we have Mr. Dr. Anish Roy Chaudhary, who is an alumnus of ISC Bangalore and currently working as a data scientist at a lead at a reputed at one of the top at one of the reputed MNCs in India. So I'll be handing over to Dr. Anish now. Dr. Anish, can you hear us?
Yeah, I'm there. Thanks, Gaurav. Good afternoon, everybody. Am I audible?
Yes, sir, you're audible, sir.
Very good. Do we get started then?
Yeah, we can start now, sir.
Okay, great. So I see like around 8 participants in total in the Zoom chat.
Yeah,
I'm pretty sure people are logged in through Facebook, right? That's
yeah. So I would just like to add there one more thing. Everyone, we are also live on Facebook. So if anybody is having questions or queries, they can comment there as well. We will be entertaining those questions at the end of this webinar, and this webinar will be a 2-hour-long webinar. So we will take a quick 5 minutes break after the first hour, and that's how we'll proceed. So again, handing over to Dr. Anish, you can carry on, sir.
Sure, great. Let me then share my screen. And let me know if everybody can see the screen.
Yes, we can see the screen.
Very good. So this is basically following over from where we ended last time. So I'm just going to quickly go through what is it we covered in the last set. So we started off with what is R. We kind of introduced the concepts of R Studio, preliminary data assignments and math operators, vectors and matrices, and we were discussing vectors and matrices, and there we had covered up to vectors. So today basically we are going to start with matrices, go over to a little bit of data frames and stuff and lists, and have a small fun quiz, just like a pop quiz in class here. And maybe we can take a break after this ends, and then we'll after the small break we'll come back and roll over to session 2. Meanwhile, do keep putting those questions in the QA block, and we'll handle that end of the session.
Yeah.
All right. So getting started, guys. As you may know, or all of you can recall, your class 10 math, a matrix is a collection of data elements arranged in a 2-dimensional rectangular fashion. Now, how do we go about doing this in R? Well, if you see on the block, you have a matrix A, which is 1, 2, 3, 4, 5, 6. It's a no-brainer that it has 2 rows and it has 3 columns. So that's what it is. How can we define such a matrix in R? Well, R has an inbuilt command called matrix. And if you recall the previous session, this wonderful, powerful command called C, which kind of collects elements. So you say that, okay, I want to create a matrix which has 2, 4, 3, 1, 5, 7. So the matrix I'm going to create has 6 numbers. Now you have to also tell R that, okay, how do I want these guys to be arranged? Now you say that, no, I want 2 rows and I want 3 columns. Well, R understands that you want 2 rows and 3 columns, which means you have 6 numbers, but you still have to tell R that, okay, how do I take these 2 rows from the data input which I'm supplying to R through the C command? So you say that by row is equal to true. Moment you specify by row equal to true, what happens here is R understands that it has to take the first row first. So it takes 2, 4, 3 as the first row. Then it takes the second row, which is 1, 5, 7, and then it gives you the matrix here A. And that's how you get A out here. Now, let's say you've been successful to actually code this in R and do the same, which we shall quickly show you here in this R Studio bit here. So if we are going to, I'm just going to kind of clear this, and don't worry about the code. All of this would be shared with all the participants here by the organizing team. Okay. So this is just for a kind of in class, just to show you how this is getting created. So we define a 2 by 2 matrix here, A, and just the command which we explained here. And then if we kind of print this matrix, there you see 243157. So that's how it comes out here, 243157. Going back to the deck here, let's see now how we can play around with the matrix. So we've created a very simple matrix. Let's play around with the matrix part. Okay, let's say I want to extract the second row, third column, which means I want to extract the second row, third column, which means the lucky number 7. I want to extract the lucky number 7. How do I do that? Well, I subscript this matrix A with 2, 3, that is the row position and the column position, and I assign it to a variable called A23. This variable might as well be X, Y, Z, A, B, C, triple X, call it whatever you like. So it gets assigned the value which is in the matrix A in the column position in the second row and the third column, which is the lucky number 7. Okay, so that's how you extract one element. Can we extract more than one element? Yes, we can. So let's try to extract the whole row. So if you look at the difference between this command and that command, this command said row 2, comma, column. Now this command says row 2, comma, and you don't specify anything. It picks up all the columns. That means it picks up basically the entire second row, and we are assigning that to a variable which I have purposefully named as A row 2 vec, but you could name it as triple X, XYZ, ABC, whatever. So that's how you extract one element. That's how you extract a row, or you could have done a column, either way. How would you then extract a submatrix? Let's say I am interested in extracting this submatrix 2415. How can I extract any submatrix from a given matrix? The procedure style is the same. So here you have specified A row and A column position. Instead of that, you say a starting and an ending position, comma, starting and an ending position. So what you are prescribing here is, please pick up rows 1 to 2, columns 1 to 2, and that gives you this submatrix right here. Let's quickly see how this looks like in R. So I bring the cursor right here and I run this piece of code, and A23 comes, and now I have to write out A23. Sorry, in the command line, if I write A23 and give enter, it gives you the lucky number 7 there. Okay, let's try to extract the whole row. So now if I try to put in here A row 2 vec, A row 2 vec, and it comes up automatically, there you can see it's 157. So that's how it came out. And the same goes for this guy right here. And if we again A2 by 2, and there you see you have 2415 coming up. Going back to the deck again. Okay. So you guys have got an idea on how do you generate a matrix and how you extract pieces of it. What next then? Data frames. Now data frames, mind you guys, is the heart and soul data structure which you would come across very frequently once you formally get started in the field of data science and machine learning and analytics. So data frame is a very, very important data structure. Let's try to understand this data frame. So a simple way for you guys to understand is, think of an Excel sheet. Think of an ordinary two-dimensional Excel sheet where you give some column names, any column names, and you have some data. Think for now that data frame is something like that. Okay. Let's create our first data frame. So what we are creating here is, we are first creating 3 vectors, and the vectors are N, S, and B. They are three vectors N, S, and B. And we have covered this in the previous class. How do you create a vector? It's very simple. Again, use this powerful C operator. And you create the first vector, which is 2, 3, 5. The second vector, which is double A, double B, double C. And the third is a Boolean vector, which is true, false, and true. So now you have three vectors. Now let's create a data frame from these three vectors. We use the command data.frame, and here we supply the vectors N, S, and B. Now, and we assign that to a data frame called DF. Now we are going to run this in R. We are going to see how the data frame looks like, and then we are going to come back to the slide. Okay. Okay. Let's define those individual vectors now. So we've defined N, S, and B. If you want to check what's contained in N, S, and B, we could do that. This is what is N having, S is that, and B is that. Okay. So that's your N, S, and B. Let's now define this data frame DF. And let's try to see, I'm just gonna zoom in a bit here. Okay, better, I guess, slightly larger. So good to see. Let's now check out this data frame DF and see what's inside this DF. Okay. Well, you've seen this data frame has automatically taken over column names N, S, and B. And how did that happen? Well, let's come back to the slide and try to understand a bit. When you've supplied these three columns in this order from left to right, what R does internally is it creates a data frame with those vectors as columns from left to right. It keeps the same order. The name of the column by default is the same as the name of the vector from left to right. So left to right, the vectors were N, S, and B. R has treated the column names as N, S, and B from left to right. And that's what is coming out in the data frame. Okay. So that's how you create a very simple data frame from a couple of vectors. Now the questions you might have is, what if the length was not the same? Well, let's go back to the definition again. A data frame is used for storing data tables. It can be treated as a list of vectors of equal length, mind you. For example, the following variable data frame is containing three vectors, N, S, and B. So if you didn't have the equal length, you wouldn't have this nice rectangular structure then, and then you wouldn't be able to create this one. Continuing a little bit more on the data frames, those of you who love cars or are maybe from a automobile engineering or a mechanical engineering background would probably appreciate this particular data frame. It looks very confusing to you, but let me go back and try to explain this, what this is. Okay. So when you install R in your RStudio, and don't worry about the background going dark, it's just a little power off which happened here. It'll probably come back. A little R gives you a lot of inbuilt data frames or data sets to play with. One of the very famous data sets which R supplies is called empty cars. What is this empty cars? What does this have? And what is this command head doing here? Very confusing, right? Throws you off the plate. I'll come back to you. First of all, the command head operated on a data frame displays the first 6 rows of any data frame. That's what the command head does. Now, when you do that, you actually get to see what is inside this data frame. So the first 6 rows look like this. Okay. So you have these column names MPG, which is basically miles per gallon. Cil would be the number of cylinders the engine has. This would be the displacement. Horsepower, something here, I don't know. This would probably be the manual versus the normal gear, and probably some information on the gear and the carb. So these are all very technical data points on car models, and these are the row labels. So this is a Mazda, Hornet, blah, 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 whatever cars they have here. So this is basically the inbuilt information about a couple of car models and their cylinders, displacements, engine capacities, and the like. Okay, let's try to see if this is really in R or is this a bluff. Okay, let's try to display it here. Okay, so see, when I did head empty cars, this is what came out. So empty cars is a big data set and it's inbuilt and it's provided by R. And when you do head, you just display the first 6 rows to it. Okay, now we'll go back to the deck and see what else we have. Okay, so now you know that we have this where there is some row label here and there is a column label here. Now let's say in the previous slide here, when we try to extract a particular position from the matrix, we supplied a row position and a column position. Now the matrix is gone. Now we have a data frame empty cars. And I want to pick up the information at a certain row position and a certain column position. Only I don't have a row position. I have a row name. I have a row label, which is Mazda RX4. And I have a column name called cylinder SIL. Can I give this in quotes and get the information, which is how many cylinders does Mazda RX4 have? So empty cars, row position is now the row label. Column position is the column label, which is cylinder. And I get back 6. So which is what I want. Okay. What else? Can I get how many rows are there in this inbuilt data frame? Yes, I can. There is a inbuilt command called nrow. You have to operate nrow on a data frame. And when you operate it, it gives how many rows does this data frame have. Going in the same methodology, you could also do how many columns this has. And you can see that it has 11 columns. Let's test this out right now. So we are going back to R. And we are trying to see if what we said works. Yes, that works. Let's see if we can get n rows. Well, we got the number 32 here for those who can see. And we got the number 11 as well. So we are successful in getting this information out of the data frames. Okay, very good. So we get some idea of what a data frame is. We know how to create a data frame. We know how to extract certain elements from the data frame. Very good. What next? The next object which we want to talk about is lists. As you can see, it looks very similar like this one, but be very observant here. Here, the first vector is a vector of size 3. The second vector, oh my, this is a vector of size 5. How do I generate a list then? The third is a vector of size 5. And hold on, hold your breath here. I am defining an object called list, which has n, s, b, which are 3 vectors and just the number 3. Can I even do that? And I'm saying this list is assigned to x. Okay. Very, very confusing. I agree with you. Now, let me take a step back and tell you that you can think of list as a dabba. Think of it as a big container. In this container, you put in a 5-star bar, a candy bar. You put in 1 candy bar. Then you put in a packet of biscuits, which has, let's say, 5 biscuits. Then you put in 3 bananas joined together. So this big dabba has 1 candy bar, 3 bananas, and a packet of biscuits with 5 biscuits. This is exactly what list is. List is a container. It can hold different data types. Right now, our list here, X, Mr. X here, has 4 elements in the list. The first element here is a vector which is 2, 3, 5. The second element here is a vector of strings which is A, B, B, C, C, D, D, and E, E. The third element of the list, mind you, I'm going slow. I'm emphasizing on the fact that third element of the list, okay? The third element of the list here is a Boolean vector of size 5 and it contains true, false, true, false, false, this vector basically. And the last element of this list is just an ordinary integer number 3. So this is a very strange list. It has different guys occupying different positions of the list, 1, 2, 3, and 4. Let's try to see this. Okay. Okay. So this is the list. I'm going to run this here and try to create the first vector, second vector, the third vector. Now we are going to try to create the list by the command x equals to list nsb3. Let's see what happens here. Okay. I'm going to display x. Now notice what came out. Something funny came out, right? You have a letter 1 which is in 2 square brackets, and then you have the number 235, an array 235 or a vector if you might call it. Then this 2 with again double square parenthesis came, and then a single square parenthesis with 1 came, saying it's A, B, B, C, D, D, E. Then the third is true, false, false, and the 4 is 3. Let me explain this part a bit out here, okay? This means this is the first, this means this is the first object of the list, which is a vector, which is 2, 3, 5. The first position of the first object starts here and it is 2, and then the other positions come. This means this is the second object of the list, and that's a vector which is A, B, B, C, C, E. The first position of that vector starts in this line, and the first position is occupied by double A. In the same fashion, you can understand the rest of the gang out here. Okay, so that's how this odd structure looks like. Coming back to the deck, this is what it is in a more compact fashion. This is how the list looks like. Okay, so that's a list. Mind you, we studied a data frame. A data frame had to have exactly same length of vectors to combine it into a data frame. A list, on the other hand, has capacity to take a vector of different lengths, a number. So a list can contain anything basically. Okay, that's what a list is. Okay, now as we played with the data frames, let us play with the list also, right? Let's try to slice and dice, as they say, a list. Okay, so here be very, very careful when we are going slow. There is a meaning to the double box brackets, and then there is a meaning to the single box square parenthesis here. Okay. Okay. So this is our list. This is the list we are going to play with once more. Keep this in your mind. 2, 3, 5, A, B, C, D, E, true, false, false, and 3. Okay. The first thing we are going to do, just like we did for matrices, the first thing we are going to do is we want to create a sublist from a given list. How do we do that, and how can we explain the code here and the result? Give us a second here and it'll be very clear for you guys. Look at the complete list. This is your complete list. Look at how we are doing the sublist here. We are saying, hey, from this list, I want list items 2 and 4 to be combined and become a sublist called child list. Okay. So what is list item 2? List item 2 is A, B, B, C, C, D, D, E. What is list item 4? List item 4 is just the number 3. So if I were to create a new list called child list, which has the list item 2, list item 4, my new list would now have only 2 elements, 1 and 2, the first being this string and the second being this 3. Let's try just this part out in R and then we come back. Okay. Let's extract this child list out here and let's try to display it out. There you go. Okay. So coming back to the deck, So now we've extracted a child list from a sub list. Let's slice the list to extract one entire member. Now remember this. Here we extracted two members, 2 and 4. Here we are extracting one number, which is just the 2. Okay. So we extract member 2 here, and that is your string A, B, B, C, C, D, D, E. And we call it second element slice. We could have called it triple X, A, B, C, whatever. When we extract this and display it, only this comes out because that is the second member which we have extracted here. Okay. So let's try to display this. We'll go slow. We'll do one by one. We're going to display this in R now. So we have sliced the second member, and we are going to display the second element slice here. There you go. The second element slice comes right up here. Okay. Now we are going to do something really interesting, guys. Okay. What we are going to do is we are going to double reference this in the same position and see what comes out. Okay. So if we did this, this is what came out. Now, if we are going to do this, let's see what comes out. If we double reference in the same position, let's see what happens. We go back to R, we double reference it out, and we get our second member here. Now, to the untrained eye, they may look the same, but to the trained eye, there is a stark difference. What is this difference? Let's see. To the trained eye, the first example was we sliced the list to extract a member, but the result was a list of size 1, which had a vector A, B, B, C, C, D, D, E, E. Now, in the second case, when we double referenced it, here we directly referenced a member. So the output looks the same, but it's not a list. And I'll prove that to you. It's not a list. What it is then? You can guess what it is, but let's try to find out from R itself. Let's see if this command works out here. Okay. Okay. So it came out as a character. So it's basically a character array which is there. It's not a list. Could we do the same for the second element slice and see what comes out now? See, when I do the class, that means the type of data, it gives me the list. So this is what I was trying to explain here, that when you do a direct double reference, you just pick out the member there. When you do like this, it's like, okay, I want element 2 of the list and I'm going to make it a sub list. So this is a very subtle difference, guys. It might confuse you in the first go. It'll take a while for this to sink in. Okay, I'm just giving you the heads up. It might take a while to sink in. Now is something even more powerful. Okay, now you guys are clear that if you do double referencing, you get the member of the list, which is this character string. Now a character string now has 5 elements. It's a character string. It has 5. So if I were to select the first element of this string directly from my list text, could I do that? Yes, there is a way to do that. So it's a two-step process and it goes from left to right. Just like we write, it goes from left to right. So x2 double subscripted 2 would give me this A, B, B, C, C, D, D, E. So it goes inside something called a second member. Now the first object of the second member is double A. I could have done it in 2 steps. Will x comma 2 comma 4 work for sub list? Let me type the answer here. Check it out. My guess is we have to use C. Okay. So Second member sub-referenced to 2, double reference to the first member gives me A. Let's try to do that in R really quick here. Let's try to do that in R really quick here. Okay. So we are here, we are directly referring a member of the list. Second member is X of 2. And if we once again display second member, it's this. Now what we want to do here is second member 1 is double A. So instead of doing it 2 times, instead of first getting the second member and then taking second member double A, the example we gave here was a slightly different one. So the example we gave here was that we could use directly X double subscript 2 followed by another subscript 1. So instead of doing it by parts, we could have done basically this and then this, and it would have given us the same result. Okay, so that's what we are trying to say here. Okay, so going back to here, and okay, there is a request from Ashish that I missed the matrices part. We'll see. We might check that. If the time permits, we'll scroll by that. Okay, no issues with that. Okay, fine. We move ahead with some initialization concepts here. So you guys have seen how we created variables with vectors. We've repeated stuff. We've done matrices and we've done data frames and we have done things like a list. Okay. Some fundamental initialization concepts, which is like a repeat or a little bit more than what we did in the first lecture where we were trying to repeat and get various stuff. We'll do this in R and we'll do it slowly, then we'll come back here and we'll discuss. Okay. Okay. Here we are creating. Okay, so this, one second, leave this out. We'll follow here. We'll follow the deck here. We are creating a variable 1 and we are assigning the value 5. No brainer to that. We'll type it out here. Let's run this and let's display this. You see, it's simple. It's just assign the value 5. Nothing more than that. Okay, it's a simple variable assignment. What next do we have in the deck? We have here a numeric vector of length 10. Fine. How can we initialize a vector to be numeric and have length 10? Mind you, this is initialization. We still haven't populated it with any numbers. Let's see if we were to do this, what comes out. Okay, I'm just going to copy this line as it is. Go to R and try it out. And then display the same. Okay. The moment you initialize a vector and say that, hey, the vector has to be a numeric vector of length 10, R creates a vector of size 10 populated with zeros. If you want to check what this guy is, the nature of the beast, this is what we could do. Could run this guy out. It's a numeric. So it says it's a numeric vector here of size 10. And that's because we said mode equals to numeric and length equal to 10. This vector command initialized this guy here to be a vector of size 10. Okay. Cool. Let's see the next line. Going back to the slide mode. Initialize the vector with 5 repeats of 10. then 5 repeats of 20. What does this mean even in the first place? This means I want to have a vector which has 10, 10, 10, 10, 5 times, 20, 20, 20, 20, 20, 25 times. Okay. Can we do that without writing 10, 10, 10 and 20, 20, 20 like we can? We use the repeat command here in a more complicated fashion. So we say that repeat, then this is 10 and 20. So this is like two brothers. Repeat these two brothers 10 and 20. A special command here, each equal to 5. So repeat 10 and 20. This couple, this brothers, whatever you call them, each 5 times. So 10, 20, 5 times. Let us see what comes out if we were to execute this command in R. Again, I'm going to copy as it is here. Copy it as it is. Go to R. Type it out and see what comes out. So each brother got repeated here, and you have 5 tens followed by 5 20s. Okay. Cool. Okay. Now we've just seen that we've initialized a vector. We've created a numeric vector of zeros. Could we do a data frame? And then could we populate the data frame somehow? Okay. Let's see. So when you give as.data.frame, sorry for that. When you give this powerful command as.data.frame, it converts the structure inside it to a data frame. Now remember, I told you that a data frame can be thought of something like an Excel sheet or a 2x2 matrix. So let's create a dummy 2x2 matrix. Let's encapsulate it with this command as.data.frame. And let us see what comes out. Okay. Okay. So we are going to go back to R. We are going to create an empty data frame, and we are going to see what is inside that data frame. And don't expect anything to be there. It's just going to be an empty data frame. Anyway, we are still going to do it. Let's run this guy. We've created something here. Let's see what is in this beast. Okay, interesting. It says NAs. Now, where did that come from? My God, I didn't know that it's going to have NAs. Really, seriously, I didn't know it had NAs. I thought it would be blanks. Okay. Then where are these guys coming from? And what are these guys? These V1s, V2s, V3s, what are they? And then you have these interesting guys, 1, 2, 3, 4, 5. So very interesting out here, guys. We created an empty data frame. We displayed it out. This data frame, we defined it from a matrix. So it was born. The mother was a matrix who said, my child is going to have 3 columns and 5 rows. And then we cloned this child to be treated as a data frame. And this 3 rows and 3 columns and 5 rows came out in R like that. Now, because it is an empty data frame, R put NA, which means nothing in it. It's like blank there. And what is this V1, V2, V3? Now remember, when we created a data frame before from some vectors, by default, the column names of the data frames were the names of the vectors. Here, do we have any vector? No. So it's just a blank matrix. So by default, R assigned column name V1, V2, V3 as default column names, and these guys got the row labels also 1, 2, 3, 4, 5. That is system generated. I had nothing to do with it. Believe me, R did it. I didn't do it. Okay, good. Now that you know. Now, since we know that our data frame has 3 columns, 5 rows, we now want to populate it. We now want to fill it with some numbers. And what is the numbers we want to fill it with? We want to now fill all the 5 rows with 1, 2, 3. Can we do this in an interesting way instead of doing it position by position? Well, one thing is evident that 1, 2, 3 is a pattern which has to be repeated 5 times. Can we think intelligently here? We have a pattern, we want to repeat 5 times. So natural thinking tells us somewhere a for loop is going to come out of nowhere, which is going to run from 1 to 5. Somehow that for loop is going to say, hey buddy, row position, fill with this pattern, then go to the next row position and fill with this pattern. Can we do something like that? Well, this is what this we are doing here. We are saying for I in 1 is to 5, which means run a for loop, start I with 1, end at 5. Then this is subscripting of this data frame, which says row comma column. So this is I, which is the first row. Put 1, 2, 3 there for all the columns. Now by default, this data frame has 3 columns and we are supplying to it 3 numbers. It will automatically put the first number in the first column, the second number in the second, the third in the third. That's how it's going to do it. This operation is repeated in a loop and with the row counter. And the obvious result is the 3 rows will get 1, the 5 rows will get 1, 2, 3. Let's try it out in R. Okay, where can we try it out in R? We will have to type it out basically here. I'm going to go here. I'm going to try and copy this out from here. So of course I have to first create this which is created. Copy. Go back to R here. Now look at this. When I place the cursor here in the for and I press run, look where the cursor stops. The cursor didn't stop here. It covered this whole for block and it came right here, which means if it's a block command and you place the cursor at the start of the block command and press run or execute the code, it'll run the whole block. Your cursor will be at the next line. Let's now try to see what is inside this guy. I'm going to display it out here again. Now see what came out. Okay, now you see that your 3 columns v1, v2, v3 have 1, 2, 3 and the 5 rows have been populated out neatly and cleanly there. So that's what was we were trying to do out here. Okay, a small break here, a small pause. There is a small pop quiz coming up for you guys, and this is it. Okay, the pop quiz will come up. Before we go to the pop quiz, we don't want this ugly naming convention here. We want to have meaningful names to vectors or data frames. Is there a way we can label or name a vector or a data frame? Yes, there is a way to do that. Let us try to see how we can do that in this case. We will take the example of a list. You could repeat this with a vector or anything. Okay. Let's see what happens here. What we did here is we said my list dot names C column 1, column 2, column 3. Now what is my list? Even does that even exist? Let's try it out. Of course, we did expect that my list will not be found because there is no my list here. Okay, so if you were to create a my list, then let's try this out. We have created a very blank list, which is using the same command as the vector command. We've created a very blank list, which is called my list. My list doesn't have anything. And we have already defined my list names below. So my list names has column 1, column 2, column 3, and we've created this empty list, my list. So let's see again now what my list has, and does it work? Again, it is not there because the first element itself was not there. Okay, so now we know that we first have to create the list before you can name them. You need to have the baby first before you can name the baby. So let's create this baby out here. Now let's see what is there in my list. Okay, my list now is a list which looks like this, and we'll see why and what it is and why does it look like that. We'll just take sorry for this. We'll just go back here to the present. I'm sorry, I think I lost the presentation. One second. Yeah, sorry for that interruption here. Okay, let's create a list with 3 vectors of different length. Let's call it my list. My list is A equal to 1, B equal to 1 colon 2, and C equal to 1 colon 3. So my list has 3 elements. The elements are A, B, and C. The first element is a vector which is of size 1 and it just has the number 1. The second element is a vector of size B. It has 2 elements, 1 and 2. The third is a vector of size 3. It has 3 elements, 1, 2, and 3. Okay. So basically my list has these 3 guys. Okay. Now we were trying to name my list, but my list didn't exist. Now my list exists. Can we now name my list here with these columns, column 1, column 2, and column 3? Let's try this out. See what happens here. Okay. We are going to rerun this command mylist.names. And we are going to redisplay what is there in my list. Okay. Now you see that I'm sorry, I typed mylist.names. I should have just typed my list. Yeah. Now you see that mylist.names has column 1, column 2, column 3 as the information in it. And when I typed my list, it gave me back the old list. Nothing happened here. What is the missing piece? What did I do wrong here? What went wrong here? Nothing went wrong here, guys. I'm just trying to explain that you need to have the baby first before you can do anything. So we produce the baby here. Somebody, the grandfather, has to decide the name of the baby and write it in his nice red diary. My grandpa wrote my name in the my nice diary called mylist.names, and that is the diary, and this is my name. My name is column 1, column 2, column 3. That's my name. The red diary is called mylist.names. It could be replaced by X. It could be replaced by X here. Okay. Let's display X. X is nothing but having 3 pieces of information, column 1, column 2, column 3. I have already created a list with 3 vectors of different names here, which is called my list. Okay. I could as well do the following. Create a test list and maybe populate it here. Okay. So I have created a test list which got this information, which has 1, 1, 2, 1, 2, 3, but still nowhere could I name it. Okay. Is there a way I can name this guy out? Well, there is a way, and we shall come back to that. I'm just going to quickly take a pause here and see the QA. What is displayed as $A and rest as $B and $C? Very good question here, Deepayan. I'm answering it on the call. So it says that $A is the, so remember when you created a data frame, by default, the name of the column of the data frame was the name of the vector. In this example, we created we took 3 vectors and we created a list. The first element of the list is $A. It represents that it is the A vector which is there. It's created from there and it has 1. $B is something like a column name because by default it took the name of the vector which is B, and it says $B. $C is the same funda that, hey guys, I don't have a name. My vector name was C, and that's how I was created in this world, and that's why it is coming as $C. Okay, that's how it is. Okay, so that's your answer, Dipayan, on the call. Okay. Okay. Why is there a quote and all those quote stuff? Put it there in the QA. We'll take off these nitty gritties there. Okay. To the organizers, could we have a break now and we can come back and continue the part 2 of the session?
Yes, sir. So actually, we can take a break now
Yeah.
since we'll be continuing from the next PPT after 5 or 10 minutes. So I'll request everyone to stay online and or at least come back in 5 minutes.
Yeah, Gaurav, a small thing. So one of the audience here requested a quick recap of the matrix. So
Yes.
when we come back, I'll spend 2 minutes on this PPT, recap that, go to the second one. Would that be good for everybody? Because a
Yeah.
few people might have joined 5 minutes late. For
Hmm.
their convenience, we should just recap the first 3-4 minutes and then jump
Yeah.
to the next one. Sounds
Yeah.
good,
Yeah.
right?
Yeah. Sounds good, sir. We can do.
Perfect. Perfect then. Thank you so much.
Start with a quick recap of the last presentation and carry
Good.
on with the next presentation, sir.
Very good. So before we go to the recap, one small thing I had missed out before the tea break or the coffee break was this. So we were discussing that this list got birth. My grandpa wrote my name in a red diary, which is called X, and I got my meat here 1, 2, 3. What I didn't get was I still didn't get my name. Nobody told me how am I going to be named. Okay, so there is a command called names. You can use the name command over any object. So here the object is test list and you have to supply it with the name. So in this case, we supplied a string of column names to a variable called X. And then we said names test list comes from X. When that happens, when we type test list, now you see this $ABC wala funda gets changed. It becomes column 1, column 2, and column 3. So now we have created the baby called list. We've given it some muscles, hands, teeth, and we've also renamed it as per the wishes of its grandpa who wrote it before he died in a red diary called X. Okay, so that's where you are. We want to quickly take the clock back to the matrix part for the sake of our friends who've joined few minutes late, and we are going to just quickly revise this one slide. So bear with me, please, the rest of the folks. So folks, so you have missed the first 3 or 4 minutes of this session. What we did was we introduced matrix and how you can define a matrix in R. It's very simple. Let's say you want to define the matrix like a 2 rows and a 3 columns. Okay, and the numbers you want to supply are 2, 4, 3, 1, 5, 7. And how do you go about doing this? Well, very simple. First and foremost, you have to use the matrix command, which is a no-brainer. You're creating a matrix, you must have a matrix command. So you create this matrix command out here. And then what you do is you say that C, this all powerful C, and you give all the numbers you want to throw in the matrix in the order, some order, 2, 4, 3, 1, 5, 7. Then you specify that my matrix has 6 objects. It has to be either a 2 row 3 column or a 3 row 2 column. That's where you get 6. So you say it's a 2 row 3 column. Then this very strong and powerful command by row equal to true, what this does is it tells R that look, the big string I supplied, okay, the big string I supplied, take this information by row. So what R does is it takes the first row, puts it in the matrix, takes the second row, puts it in the matrix. Now you know how you've got a matrix which is 2, 4, 3, 1, 5, 7. Okay. Then what we extra discussed in this deck was, now that we have a matrix, how can we slice it and dice it? Well, slicing and dicing a matrix could mean I want to get one particular element, I might want to get an entire row or entire column, or I want to get a sub matrix. We've covered all the three here. So to get a particular row call position, it's very simple. Matrix subscript row call position, you get your guy. Here is the lucky number 7. Mind you, the 7 is not coming from this A, it's coming from this matrix here, which we defined. That's 7. You want a whole row or a whole vector? Very simple. You want the whole second row. Start with 2 in the row position, comma. Do not give any column position. By default, it will take all the columns, which in essence means you have the entire second row out. Okay. Extracting a sub matrix. How do you do that? Well, going by the same logic, you specify not one position but a range. You specify a range for the submatrix 1 to 2, 1 to 2, and there you get your submatrix here, which is 2, 4, 1, 5, which is basically this position here. Okay. So that kind of wraps up the first session with this recap of the matrix. We would now jump into the second session, but before we jump into that, guys, a small something for you, and you can either type this in the chat or you can put it or email it or whatever. So here is a small quiz. Okay, this is a true false quiz. You have to tell or type whether the answers are true or false. First question: all elements of data frames are vectors. Is it true? Take a pause, but you could think about it. Well, it is true. All elements of data frames are vectors actually. Okay. Let's see what the second question is. The second question says all elements of the list must have. Can you guys tell me, is it a true or a false? I'm pausing. I won't show the answer. All elements of list must have the same length. Let's see what the chat guy. Okay. Yeah. Let's see here. What it is false. We showed that it can be the different lengths. Okay. Last question: true or false? Data frames are the most flexible structure in R. I'm going to take a pause and see the chat puts. Data frames are the most flexible. Here is the googly you guys got. Sorry for that, guys. List is the most flexible structure in R. List is such a flexible structure that it can have objects of different length, of different type. A list can even have a data frame as one of its members. So, which means you have to go back and revisit the deck, but that's okay. I didn't want to scare you guys. Okay. With that, we close this deck and we go on to the next one. Thanks for listening to part 1. Let's welcome part 2. Okay. Okay. So I think, Gaurav, you there on the call. So how much time do we have for this session? Do we have like 40 minutes or can we stretch it to an hour?
Yes, sir. We can stretch it to about 50 to 55 minutes.
50 minutes. Okay. Could you help me out? Could you give me a warning at the end of 50 minutes so that,
Yes.
like at the end of 40 minutes, so that
Yes.
we know that we have 10 minutes left?
Yes, sir. We can do that.
Very good. We will pace ourselves accordingly then.
Yeah.
Okay. Fine. Thank you. Okay. Agenda part 2, which will wrap up the session of introduction to R, is now you really need to know serious stuff to get working. Okay. Data doesn't come as matrices, data comes in CSV files. So which means you need to know how to read a CSV file. You need to know how to extract relevant portions and do the processing, and you need to know how to write. So what this slide essentially does is it kinds of, how do you share the, oh yeah, Gaurav will share the PPT. So what it does is, guys, it just gives you a structure, the very basic structure of how do you process something in R with CSV data. Going ahead. Okay. This might look a very involved slide, very involved deck. Bear with me. We will first understand the deck. Then we will try to understand the syntax, and then we'll try to work it out in R. Okay. Bear with me here. This as I'm saying is a very involved deck here. Okay. Let's try to understand the deck. It's actually a case study. It's nothing less than a case study in itself, mind you. And we will be sharing the case study, the R code, the CSV files, everything for you guys. So don't worry, you will get it. There will be some way for you to download all of this. Do not worry. Okay. Let's see what is the case study now. Read a file called car sales and report car model and make for those models having sale value greater than 300. This might come right handy for people working in any sales job right away. Let's say you're working in the dealership of Toyota or Nissan or Maruti for that matter, and you need to do these quick analytics which you had to write macros in Excel for. Now you can quickly do it. Let's first go take a step back, see what the data looks like. Okay, I'm going to escape it out. Okay, we have a file which is called car sales. Very good. So this is an ordinary ordinary vanilla flavored Excel file, CSV file, which has car make here. These are the makes. This is the car model. So Toyota Corolla 120. This is all I knew that time, so I could make it. Today maybe I would have put in more. You can consider it as units sold by the numbers. I would say probably units sold in a month in India or in a month in Maharashtra. Maybe, I don't know. I'm not that good in sales, so you could make out what the meaning of this might be. But this is basically number of units sold. This is the model. This is the make. That's your CSV file. Okay, that's what it is. Okay, going back to the deck. Trying to understand the deck here. Okay, objective: read the file, find out the car model and make for those models having sale greater than 100. Very easy objective. All we have to do is list that manufacturer and model name for which the sales is greater than 300. Simple objective. Let's see how we do it. First thing first, you have to read the file. No shortcuts to that. The command is the command is read.csv. Once you read a file which is read.csv, of course you have to have the file in some folder. You have to specify the folder, and I have not told you any of that, which we shall see now. When you read it into a variable car data, by default it becomes a data frame. So car data is now a data frame. Very good. We know what a data frame is. What next? We have to get the sales for those models which have sale value greater than 300. So here we have to do a filtering. How do we do a filtering? R has a very powerful command called subset, which works on data frames, where the command is like subset. You give the name of the data frame and you give the condition of the subset. So what is the condition? Sales greater than 300. What is the column name which has sales? It is sales with a capital S. So this line is understood. And the resulting subset is also a data frame, which is going into another data frame called top sales. So that top sales is a subset of car data, only having the information of those manufacturer and cars which have sales greater than 300. Is that all, guys? Is that all which the problem statement says? My answer is no. We have failed to read the problem statement completely. It also says list by highest sales first. Well, I forgot that. Sorry. Can we do that? Definitely. All we have to do now is order a data frame in descending order of a certain column. Now hear me out very carefully. We have to order a data frame in descending order of a certain column, and we have to get that in some other data frame which we want to publish or write. How can we do that? Let's have a look now. The data frame top sales already has what we need. It just needs to be ordered. So the command within the box bracket, you have to give it within the square bracket, is order. Negative means descending order. If you do not write the negative sign, it will take in the ascending order. In the parentheses, you have to mention the name of the column. Now your question might be why this dollar sign is doing here. Very good question if you have not asked it already. Now you have to reference the data frame, sub-reference the column. So it's like mother dollar child. I am operating this order command on mother dollar child. What does this small comma doing here? The small comma, what it does here is it means once I order this or whatever I do here, please select all the columns, and all the columns after this ordering will be put or assigned to another data frame called sorted top sales. And now I'm going to display the sorted top sales here, and I'm going to write it out in an output file. Okay, let's do the following and then let's do and see what comes out. So we are going to write it in an output file. The command is write.table. I repeat, do not worry about the syntax. This syntax is basically the standard syntax to write a file which is comma separated. Okay, I'm gonna, you can throw in your questions. We will do that, handle that later. Okay, cool. So I'm going into the R now of this thing and seeing how we can do it. So we close R module 1, don't save it, and we try to open R module 2 here. This is R module 2, guys. Okay. Okay, it says it cannot open car sales.csv. Oh my God, I don't even have this file. Let me check the folder. Well, it is there. What is going wrong here? I see the folder is there and I am not able to see it in R. Is there something wrong? Should I have done something? I go to session here and I set working directory to source file location. Then I see what is my current working directory with this command. Now I am in the correct working directory. Now it should be able to view this file. See, it could. Let's run it. Now you see card data is like a data frame and it has all this car information. Now what is the first thing we did? We want to subset it into another data frame which is called top sales. Let's try to do that. Okay. Now what we said was we want to sort this in the descending order. Let's do that as well and display it out. Well, that's it. Maruti Alto, no guesses there. This is the clear winner. It has to be the clear winner. Okay, no options there. We are going to write it out into an output file. Let me explain this command for you guys. This is the name of the data frame. This is a command file. This is the name of the file which you want to write it into. It's a comma separated file. Give this word keyword. I do not want this row numbers 1, 2, 3 or whatever coming out here. Row names equal to fol is a good standard thing to do. Let's write it out. It gets written out. And what happens is this is what gets created. There you go. This is your output. Okay. Now let's say that, you know, I didn't attend this webinar session by Amity. I was a naive guy and I still believe in Excel. Okay. And I think Excel is God, and it is, and it does a lot of things. So what would I have had done here is that I would have to write some macro. Let's say I don't even know macros and stuff, right? I'm a very, very stupid guy. Then I would be doing something very dumb like, okay, I physically see, okay, these are above 300. Okay. I would be doing something so stupid like that. And then I would have to select this column and I would have to sort it, continue with the collect selection, smallest to largest, largest to smallest. This is what I would have to do. Now imagine doing this on a CSV file with 1 million rows. Good luck to your laptop and yourself if you could get it done, guys. Okay, good luck to that. So now you realize a little bit, right, what I'm trying to hint at. Okay, we'll get back to this one. Okay, cool. Somebody in the chat. Yes, I think so. Yeah, probably yes. Probably yes. That card data thing. Yeah, probably. My bad if I have not done the right naming here. Okay, cool. Miscellaneous functions. I know we have bugged you guys a lot with vectors and populating vectors, but this is something very important to do with strings and vectors here with some random set of commands. I couldn't find a good topic to put it in, and that's why I'm gonna do it here. Can you please repeat the previous slide again? Previous slide meaning you mean this one. So what we said here is that we read a file. I'm just going to go through it slow. We read a file here which is called as car data, car sales file, which the name of the CSV file is car sales. It's going into a data frame called car data. I understand the confusion here. I have given an underscore here and I have given a not given the underscore here. That's creating the confusion. Probably I should change it here for once and for all and save it. And probably in R I have done the right thing. So see, it's a uniform. So whatever name you give there, that is the name you have to operate on. So my bad is that I have done car data here and car underscore data there. Don't let that bug you guys. Okay. So basically what we did was we got this information in card data. We subsetted it for sales greater than 300, sorted it in descending order, displayed it out, wrote this data frame into a CSV file. That's what we did here. Okay. Coming to the next set. So these are random set of commands. I couldn't find one single topic to put them in, but they're important and I thought I put them in miscellaneous functions. Okay. Let's start with the left hand side first. Okay. Now we create a vector of 5 numbers. That's very simple. We've done it many times. So vec1 has 5 numbers. Okay. Now, can we do an if else logic on the 5 vectors? If else. What is this if else logic? I'm going to write it out first and then we are going to do something here. Okay. Let's write it out nicely and then we are going to do something here. I'm going to go to R now for this part. So what I wanted to do was create a vector. We've created a vector. Let's display this vector. Okay. Now what I wanted to do is this. Let me explain it here with this. Create a notepad probably here. Okay. This is what I wanted to do. No issues with that. Okay. We created a vector. Now do the test. So this is what we are trying to do. So we've created a vector of 5 numbers. We want to check if an element of the vector is equal to 2. If so, it return true or 1, else return false or 0. That's the task we want to achieve. Let's see how we are going to do the same. So we create a vector of 5 numbers and we write if else vec1, that is this vector, double equal to comparison, is it equal to 2? If it is true, return 1, else return 0. Now those guys who are gurus in Excel know that, you know, in Excel you do something like this. You write all these if else functions. So you would be acquainted with the syntax. For those who are not acquainted with Excel and new to R, like most of the crowd here, what this if else does in single line is what I wrote in the notepad. It says if this vector 1 is having 2 in any position, return 1, else return 0. Now let's look at the numbers once more. 15, 2, 32, 45, 50. It's a no-brainer that the only position which has a 2 is the second position. So it should be a no-brainer for you guys that this output should be 0, 1, 0, 0, 0, which means it is returning a boolean of 0, 1 based on where it is true, where it is not true. Okay. That is what it is doing out here. Okay. Similarly, you can do other things like check for odd and even. You can basically check any condition in if else. If the condition is true, it will return what you are mentioning after the if else statement. So here I'm mentioning even and I'm testing for even number. If it is even, it is going to return me even. If it is not, it is going to return me odd. It's operated on 5, 9, 2 and 3, which means odd, odd, even and odd. So basically it's very simple to understand this block. So the left block, let's try to work it out in R. Okay. So here we create a vector of 5 numbers. We do the if else. This is the output of the if else. Okay, as we discussed. Let's check the odd even wala funda now. Here also it's as expected. You get odd, odd, even, odd. Okay, that's how it is. Okay. Okay. Coming to the right hand side of this. So here is a little bit of string manipulation here, mostly concatenation. So how can we concatenate strings in R? Well, you can do it in a couple of ways and you get a couple of different outputs. The first and foremost I will tell you is concatenate with the word paste. Paste is a command. What does paste do? Paste pastes two characters and creates a single string. Okay, that's what paste does. However, you notice that paste gives you a gap in between. Yeah, good question. Percentage in the previous slide is modulo division. Which means if 5 divided by 2 has no remainder or okay. I cleared that doubt in the last slide. Put it in the QA if you have further doubts on the previous slide, and we'll take it up, not to interrupt the flow of the class. Okay. So concatenation. Paste is a very simple command. It pastes two characters, but it gives you a space in between. Now I want to paste without a space in between. For some reason, I want to paste it with an underscore in between. Can I do that? Well, paste is a very powerful command. It also gives you a separator keyword. You can actually decide that, I want to have, instead of blank, I want to have an underscore. Hey man, it'll give you an underscore, no problem. Okay, no issues. Fine. Is the C operator the same thing as paste? Now here is a catch. C creates vectors. Now if you want to do hello world with C and you want to see what is there, it'll create a string of 2 words hello and world. It will create one string of 2 words called hello and world, but I want to concatenate them as one big string. Can I do that? Well, you can do that. This is a collapse keyword which you have to do then. So if you do the collapse keyword, if you give a blank, it will collapse these 2 strings with a blank. If you don't give a blank, you don't give any spaces, it will collapse the string without blanks. Now this whole thing might be confusing. We'll go through it slowly one by one. We start with the paste and then we see what happens, and then we start with the C operator and paste, and then we see what happens. We'll go slowly on this deck in R now. Okay, first we try paste. Okay, paste AB, run it. Out comes A, but with a gap in between here. There is a small space in between. Okay. Now we want to explicitly paste these 2 strings with a separator. Let's try that. Well, the separator came in. Now your string is hello underscore world. Fine, no issues with that. Okay. Can we do the C operator here and see what comes here? Let's put hello world in C operator and then run the paste command. Now you see it's not one string. It's hello, and that's another world. So it has two elements into it. Now I'm going to collapse it by keeping a blank space in between. Let's see what happens. The blank space came in between, but now it became one single string. Can I remove the blank spaces? Yes, I can. I don't give any blanks here. Let's try. There you go. Now you have a nice string, which is just what we wanted and no blanks in it. Okay. So this is basically a different. So this deck is just a random motley of miscellaneous functions, and we will continue to the next deck, which is another random motley of differential functions, but which I thought was very important. Okay. Again, guys, we are going to bug you with vectors here. Okay. Let's work this out slowly this time. Now we are again creating a vector, but interestingly, we are purposefully embedding NAs. So NA is something like null, empty, blah, 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 something, whatever. It's nothing. It's an NA. Okay. So we purposefully create a vector with nulls, and the nulls in R is denoted with NA. So we create this vec1. Okay. Now, how do we check with nulls? Is there a way we can find out which position in a vector is null? Can we do that? Yes, we can do that. There is a way to do that. Okay, this is the way. You first create a vector with nulls and then run this command is dot na, which means is na on the vector 1. Your output will be a Boolean vector, which will tell you exactly in which position there is a null. Where there is a null, it will be true. So here you can see the null is in position 4. 1, 2, 3, 4. We have a true. Again, null is in positions here. The last two positions of null, so they are also true. Okay. Now, typically, why are we doing this deck? So some of you, when you have to deal with CSV data, you get some data with nulls, and typically the ask is please choose the data which does not have null. Now, can we do that? Can we choose from a vector those positions which don't have nulls? We can do that. How do we do that? This exclamation mark is like a not operator. So what this is NA does is it tells you these positions. The exclamation mark reverses the Boolean logic, and when you put it back in the square brackets here, the net result is only those positions from vector 1 which do not have nulls is copied to another vector called no null vec. You can display it out and see it'll have 1, 2, 3, 4, 5. Now, sometimes, guys, we don't want to throw away positions which have null. We might want to plug them with 0, 100, 99, double X, triple X, or God knows what. Okay. Sometimes we want to do that. Can we then replace the nulls with zeros, which is a very, very important data science cleaning operation, which a lot of people do, replaces nulls with zeros or something else. So here we say that, okay, this is vector 1 again. Now, vector 1, and this bracket means the positions here. This bracket means I'm referencing the vector 1. Is dot na vec1. This will give this Boolean. This will give this Boolean. So wherever there is a null, fill up that with a 0. If you execute this, what's going to happen is this vector out here is going to get replaced with nulls with zeros. So 1, 2, 3, 0, 4, 5, 4, 5, NA, NA, 0, 0. So the nulls will get replaced with the zeros, and we can display it and see it, and we are going to check it slowly in R for this miscellaneous functions part. Okay. Hold on. Let's check it out. First step, create the vector. Second step, just check what we created here. Yes, it is the right vector. Can we check for null? And the reason I said is I want you guys to understand the output of this command. The output of this command is a Boolean. It's a Boolean. Okay, that's what it is. Okay. When you put this Boolean and you put an exclamation on it, can we try that also? Let's just try that for fun. Okay, I'm just trying it for fun. I don't know what will come. It may not work directly as well, or it may work inside. Okay, yeah, it won't work because I have given a is comma na. I'm going to try with the is dot na. Look at what happened, guys. Magic happened. This was the first Boolean vector, and I put this exclamation mark on the left hand side and ran it, and you got a reverse Boolean vector out. Now, moment you put this Boolean with a subscripting logic, it converts it into positions true and false. So now if I want to copy the non-null vectors to another vector, what is going inside this is a Boolean of positions, which is a reverse Boolean. Okay. This is what is going inside. So only the true would be selected and put in non-null vec. Now let's try it out. Let's display non-null vec. It only has 1, 2, 3, 4, 5 as expected. Now we want to do something smart. We want to replace the nulls with zeros in the original vector. That is what we're going to do here. Replace nulls with 0, display it out. Neat and nice as expected here. No issues with this one, guys. Okay. Okay, cool. What is next coming up on the miscellaneous front? Let's see. Okay, it still continues. Now is we are moving slowly into the data part of things and more powerful features of the data frames. Okay, let me first explain what this slide does before you guys go off the hook here or go completely lost. And then we will explain the code, and then we are going to run the code in R. So 3 steps: explain what is on the slide, go line by line, explain the code, run the code live in R. Okay, bear with me guys on this one. Okay, let me explain the slide. You have a table called customer ID and name, and you have another table which has customer number and purchase. Customer ID and customer number are one and the same. So it's like 2 tables. One table has name of the customer with a key of customer ID. Another table has what is the purchase amount of the customer with the key again of customer number. So customer number is basically the same as customer ID. It just has 2 different names in this 2 different tables. Okay. One table is obviously customer data. The other table is the sales data. No prizes for guessing which is the sales data and which is the customer data. Okay. Okay, guys. Let's first create these tables. Okay, these tables are basically data frames. Now you know now how to create this. You could do it yourself without me guiding you. You would first create a vector called customer ID. You would create a vector called name. The customer ID would be a numeric vector. The name would be a string vector. And then what you're going to do is you're going to call the command data.frame, and you're going to put this first vector called customer ID, give a comma, and then you're going to put this second vector called name, and then you're going to wrap it with data.frame and assign it to the first table called customer data. That is exactly what is happening in the first line. Absolutely in the same manner, the sales data table is happening. So these 2 lines are pretty clear because we now know how to create vectors and how to create data frames from vectors. That is exactly what is happening here. What we do not know is the merge command, which I'm going to explain in this deck. Okay. Now I need to know the information of which customer name of the customer, who and what is the amount he or she purchased. So here, can we do a merging? Is there a common column I can merge these 2 data frames with? Look very carefully. The common column is standing in front of you. It's called customer ID on the left hand side, and it's called customer number on the right hand side. Then now we have some idea as to how to write our merge command. So this is how the syntax of the merge command goes. Merge, you give the name of the left hand side data frame, which is customer data, comma, give the name of the right hand side data frame, which is the sales data. What is the field on the left hand side which you want to merge by? It is customer ID. So give comma by dot customer ID, by dot customer data equals to customer ID, comma by dot sales data equal to customer number. I will explain this line once again for you. Do not worry about it. Let me open up my notepad here. Okay. So this is how the merge command works here. So you are saying that merge, then you have to give name of left hand side data frame, comma, then you have to give the by command. So what is by which column name? That's exactly what we are doing here. We are saying that merge customer data, which is the left hand side table, sales data, which is the right hand side table, by dot customer data equal to customer ID, which means from the customer data table pick up customer ID, from the sales data table pick up customer number. Once you merge it, it will join these two guys and it will give you this nice merged data frame, which we are calling as merged underscore data. Let's run this out now. Where is the customer number coming from? Where the customer number is coming from the right hand side table. Yeah, okay. Good to point that out. Yeah, sorry. Good to point that out here for me. Thanks on that. Again, a typo on the deck. Thanks, guys. I got it. I got what you're saying here. It ideally should be. Make the small change here. Sales data. Make the small change. Yeah. Thanks, whoever pointed out. Thanks for that. Okay. It's a small typo on my part. Saving it. Okay. So now the customer data has here this. Gaurav, anything?
Yes, sir. So can you change the chat box option in your to it's currently being sent to only me, only the panelists. Can you change it to everyone, panelists and the attendees, so
Okay.
everyone will be able to give a response?
Okay, fine. Okay, I'll do that. So I'm just saying it on the call. So I got this correction here from the audience that I wrongly called both the columns customer ID. I should have done that here. I corrected it on the slide. Okay. So that correction is done here. Now it's customer number. This is customer number. So I did that correction on the slide. Okay. Fine. Let's try to do that here as well. And again, 1 second. Yeah. So I made the same mistake here. Change it out first. Okay. Sorry for the typo there. It was mistake on my part. Okay. Let's create customer data now. And let's create sales data also. Okay. And let's display these guys out once to see what's inside them. Okay. So we are going to display what's inside customer data, then we're going to display what's inside sales data. This is what it is inside customer data. Let's display sales data now. Okay. Sales data. Okay. One quick tip for you guys. Any object you create in R comes in the global environment here. If you want to really see it in a nice way, you could go to that global environment here, double click on that. It will show you here. Click here on this icon. It will open it up for you here. Okay, it's a quick check. You want to quickly check what it is. It will show you in a much nicer way than on the R panel, and you can close it then. Go back. Okay, and you could do it for any variables which you have created. So top sales for that matter from the last class, it comes out here. Close it out. Go back to the R code. Okay, it's a small tip. Okay, coming back to the merged command. So here now I'm all set. Now I've corrected it. It's customer number and it's customer ID there, and we've corrected it out. Now I can run it nicely and display the merge data, and merge data, something happened, right? some shit happened here and I'll explain it to you what happened. But before we go into the merge data, let me kind of try to explain it what merge data. Okay. Now look at what merge data is. Okay. You had customer number 1, Vinod, purchase 450, Ramesh 1, Ashish 1, Venkat Raj. So basically what this merge command did to here was it took the customer ID and the customer number, merged it out, and it kind of repeated the rows. Okay, so some information got repeated because of this one. So I'm going back to the module here. So when you merged on the customer number here and here, it kind of repeated it out. So customer number 1, 450, it kind of so there is a way where you can specify something similar to, let's say, a database operation on an inner join, outer join, left inner, right outer. We are not going into those advanced modes right now, but you could actually specify and you could avoid these repetitions which are coming out, which is the very basic join which gives everything out. Okay, you could avoid that. I will probably supply notes on that as an additional note on how it could be done after the end of the session, and you guys could get that out. Okay, no issues with that. Let's go to the next deck here, which is again miscellaneous functions continued. And now what we want to do here is tabulation kind of thing. So before we go into tabulation, what is the concept of tabulation? I'm going to explain that a bit, and then we'll tell you what tabulation can be done in R. Okay, for that I will take the help of little bit of the help of Excel. Okay. Let's say we have these entries under male, and say we have these entries under female. Okay. Okay. Now there are 5 males and there are 3 females. Okay. If this was the information given to you, the output I want is something like this. I want how many males and how many females. This is called tabulation. Okay. So I want this. This is what I want. This is what I have. Okay. How can I get from here to here? This is what I want to do exactly. Okay. Let's see how R does it for us. Of course, you have to create this. You have to create these vectors. So we've just created a big vector called gender, which has male, male, female, male. So it has this. Now we've created also another one of them called married, single, married, single, married. Okay. So first I want to do a one-dimensional tabulation. I want to see this vectors mein how many males and how many females. Can I do that? Well, one-way tabulation, the command is table gender. So all the females come here, all the males come here. It's like a count. Somebody is counting based on the different breaks. There are two types of objects, right? Male and female. So it breaks it onto female and male, does the count and gives you out here. Okay, this is what it does. Okay, let's see that how we could do that in Excel. You guys might be knowing, I'm not sure, but may not also know, I'm not sure again. Let's actually create that here. Let's create a couple of males and a couple of females. Sorry for that. And one. Okay. Now let me just see if this works. Okay, I'm not sure it's gonna work. I haven't done it in a while. So what I did was basically what I did here was I basically tried to create a pivot here, and I basically I got it. So basically what I wanted to do was I used the power of Excel pivots, and I tried to get a count of the female and the male from the raw data. Okay, those who know Excel can understand, those who don't know Excel can just skip. I just wanted to show you what it is that I was trying to do. So this very powerful command in R, tabulate gender, does exactly that and just gives you the output. Okay, there is a even more powerful command in R, which is the two-way tabulation. The command is the same, but it's a two-way tabulation. if you give two of them here. Okay, now understand how this is going. Okay, you have a gender male, male, female, male, female. So 5 entries. And you have a marital status vector, married, single, married, single, married. If we are to observe the 1-to-1 mapping of the order, male, married, male, single, female, married, male, single, female, married. Okay. If you cannot remember it, if you want to tabulate gender and marital status, it gives you an output like this, from which you can find out information like how many single males, okay, how many single males who are ready to mingle. That comes into male single 2. The answer is 2. Can we cross verify this? Yes. Male single, that's 1. Male single, that's 2. Yeah, so this table is correct. So this is a very powerful command, guys. It's called tabulation command, where you get this done. Okay. Okay, some more. So now we did some inbuilt functions. Now we are going to take you to the world of writing your own functions in R. Imagine how powerful that could be if you could write your own functions instead of only depending on functions which are provided to you by R. We'll start with the easiest of all functions in the world, which is always the hello world function. Okay, we are going to start it in R and then we're going to come back to this deck. Okay, I'm gonna clean the slate a bit out here. And, okay, so guys, we are in the hello world function. Gaurav, checking on the time, have we reached the danger mark? Do we have 10 minutes left now?
Yes, sir. We have reached the 40 minutes mark. We will have to wrap it up in 15 to 20 minutes. Sir.
Okay, we'll wrap it up in 10.
Yeah. Okay. Sir.
Okay, fine. Guys, keep streaming your questions to the QA block. And Gaurav and myself, will collate all of them. We'll have the answers posted on some place where you can download all the answers and your queries, and the text and the codes will also be supplied. So don't worry. Okay. So let's go a little bit faster now. We shall, for the sake of time, we shall show you 2 simple functions, and I'm going to quickly scroll through this deck and see what is it that we might have to skip. Well, loops we've already done, for loops, so you know that. Okay, that's all there is. So yeah, okay, probably we'll be able to cover. Fine. Okay, let's understand how do we write a function. Okay, you have to write the keyword function like this. The actual function comes inside the curly parenthesis like that. If the function returns anything, you put whatever you want to return, you put here. If you don't want to return anything, don't return anything. Give the function a name. So the function is called hello world. Call the function. This is how you call a function after you define it. So let's define this function first. Okay, very good. Look what happened when I placed my cursor here and did run. The cursor ran all of these lines together as one block. An object in the global environment got created. It's a function. It's not a data anymore. It's a function. Okay. If you click on it, it's a function. And now I'm going to call this function hello world. Let's see what happens. 2 things happened. One is hello world got printed and a null got returned, because every function has to return something. If I don't want to return null, I'm going to put here a 0 and I'm going to redefine this function, and then this hello world returns a 0. So it has to return a null or it returns a 0. Now we've mastered the art of functions. Can we be bold and brave and write a function which simulates a sum command? Okay, we'll not do this part for the sake of time. We'll do a very simple one. We'll try to sum 2 numbers a comma b. This is the simplest function you get in any programming language to do after the hello world, of course. Okay, let's try to understand the function and try to do it. Okay. Okay, so we want to write the keyword function. Since we are summing 2 numbers, you have to take 2 numbers. The numbers are a and b. inside the function, this is what is happening inside the function. Inside the function, the sum of a plus b is going into a variable called sum2, and we are printing the output with a paste command. Now instead of this paste command, let me write a simpler paste command first, simpler command first. Let me remove this paste here and just give you the output. If my function is this, let's define the function with this. Let's call the function with 5 and 10. You get an output here of 15, which is what you expected, right? This is what you expected. Now we'll change it and make this little fancier. We are going to comment this block here. And we are going to uncomment this block. Now let's redefine the function. Now you see sum is 15. Nice, right? Now I've done something fancy here. I've pasted these two strings, sum is and sum2, and I got sum is and sum2 is actually a variable with the value 15. That's what came out. So that's what came inside this part of the deck. For the sake of time, we'll leave this part out and just quickly walk you through the loops part. So for loops, guys, we have covered. While loops we have not covered. I'm just going to cover the right hand side here. A while loop is a loop which goes on and on and on till the condition in the while is true. Okay, let's understand this loop and let's understand the output. X 0, X is assigned 0. No problem in understanding that, guys. X has a value 0. While X less than 5, I guess you have no problems in understanding that till the time X is less than 5, do whatever is placed inside this parenthesis. What is placed inside parenthesis? Print X, which is getting X plus 1. This is two commands in one. First, X is getting X plus 1, and the second, X is getting printed. So when we start this work, X has the value of 0. Is 0 less than 5? Yes, of course it is. 0 plus 1 gives me 1, and I'm going to print that 1. Go on till X becomes 4. Is 4 less than 5? Of course it is. Add 1 to 4 and put it in X, which means X is now 5. Print 5. 5 comes out here. Is 5 less than 5? Unfortunately, no. Nothing happens anymore. That's why you get 1, 2, 3, 4, and 5. Let's understand the block below with a repeat break. Like a while loop, you have a repeat break also. Let's understand that and we can close the session. There is no problem in understanding y less than 0. Y getting 0. A repeat break block works like this. Whatever is inside repeat will be infinitesimally time. It will be keeping on repeated infinite number of times unless you give a break statement. So repeat y having y plus 1 with a condition after that, that if y is greater than 5, break will break out of the repeat block. Let's try to understand the output first. So initially y is 0. Repeat will just repeat that print 1 because 0 plus 1 is 1, and then it will print 2, then it will print 3, then it will print 4, and it will come to 5. Then it will add. When it comes to 5, it will still print 6 here because 5 plus 1 is 6. It will print 6, and then it comes after that to a check. Is y greater than 5? Is 6 greater than 5? It is greater than 5. It will break out of the loop, and that's it, guys. Thank you. And it will not print anything more, which also brings us to we don't have anything furthermore for the introduction to our session. Over to you, Gaurav. Hello. Yeah. Gaurav is on the call. Unfortunately, he's muted. Let me put a message here. Hi. Okay, the break part. Okay, yeah, I'll cover the break part again. Okay, guys. Okay, let's look at this loop again. It's a repeat break loop. If I didn't have the break command, it would repeat infinite number of times. It would keep repeating whatever is inside the repeat. There is a condition check I've put after the print statement, which is if y greater than 5, break will break out of this entire repeat block. Okay, so let's go through this once more. We start with y equal to 0, and in the print statement we are saying print y plus 1, so we print 1. Then the if block comes. If y greater than 5, well, 1 is not greater than 5, nothing happens. You continue like this, printing all the way till y is 5. Then you enter the repeat block. Then print y plus 1, which means 6 gets printed. Then the if check comes. If y greater than 5, is 6 greater than 5? Yes, it is. Break off the loop. That's what happens. Okay. Over to the organizer.
Yes, sir. So I think we're done, right, with the presentation. So let's go to the Q&A session, I think.
Okay.
Yeah. So there is a question from Ashutosh Kumar. He is asking, should both LHS and RHS should be of same length to be merged? So on which slide he is actually asking the question is not clear.
Okay, so the merge command is, this is what I would suggest you guys. The merge command is many ways like a SQL join command. Okay, the column name on which you are merging, so LHS and RHS basically refers to this slide, the left hand side data frame and the right hand side data frame. This is what I want you guys to actually experiment and see. Create two data frames which are of the same size, run the merge command on them. Create two data frames which are of different size. Let's say in one data frame you have one extra customer ID. Let's call it Anish, which is customer ID 6, which does not exist in the other table. Try to do the merge command, come up with what you get. I won't tell you what you get, but try to do that experiment. It's a good learning process, and I will give you guys additional material on the merge, especially on the merge command. I will create some additional R code and material and I'll hand it over to Gaurav. But good question on that.
Yes. So anyone of the attendees who are attending on Zoom can actually raise their hand to have their questions answered live right now. So we'll be waiting for a few minutes. So Naresh is having a question, so I'll allow Naresh to speak.
Yeah, please Naresh, go ahead.
Hello Naresh.
Naresh, we cannot hear you. You want to write it in the chat?
Maybe Naresh, you can type your question in the chat box and we'll ask it for you. Let me just unmute him for once. I think his connection is slow. Till that time, if anybody else is having question, they can raise their hands too. So
what you guys could do is you could post it on the QA, and if you have some difficulties, myself and Gaurav would collate all the questions and prepare an answer sheet as well.
Yes. Okay.
And I would, as I promised, I would prepare some additional material on the merge, where all different kinds of merge will be covered, and that would help you guys understand it better.
Okay, so Naresh, actually Naresh, I can't find your question in the Q&A section. If you would be kind enough to please type the question again, we can probably
for the chat question for Deepan, hold your horses a little bit. I'll create a lot of examples with the merge command where your answers will be doubts will be cleared. So merge has a lot of extra keywords to it, and that will help you answer out your queries, like whether the rows are getting repeated, how can I get the output as I have shown here, will help you out. So what happens is, when I created the deck, it was an R version, it was very old R version. Maybe R version changes came into being, and there would be probably additional keywords which I will figure out, update the deck, and hand it over to Gaurav.
Okay, okay, sir. So currently nobody is having any more questions, sir. So I think we can wrap up this session here for now.
Okay, okay. Thanks, Gaurav, and thanks for the people who have logged into Zoom, and for the other people who are in Facebook whom we can't hear. I'm sure a lot of people have logged into the Facebook live session. So thanks, folks, for that also. And stay tuned from Gaurav. We will update this deck. We will update this R code with couple of more examples on merge and hand it over to you guys. So probably what has happened is, because of the R versions, some different output is coming. I need to find some keywords and make a little bit explanatory deck on the merge.
Yes, sir. So participants will be sharing the presentation and as well as the recorded version of this webinar if you have missed something, and also the data set which has been used for this presentation. So thank you everyone for attending. Have a nice day.
Yeah. Thanks, Gaurav. Thanks for hosting.
Thank you, Mr. Thank you, Dr.
Yep. Bye-bye.